Okay, this is a introductory video to lab number 2, which is analog to digital conversion. In this experimental setup, you'll have some equipment that you've seen before, function generator, an oscilloscope, and something else you haven't seen yet is a Logger Pro data acquisition unit, which is right here. That will interface with your computer using Logger Pro software version 3.8.6.1. You should have that available in the course folder. It is a 300 plus megabyte install file, so go ahead and make sure that you copy that file to your computer from your respective section's course folder before you come to class. We will install the software when you get to class. So after you install the software, when you start to install the software, it will ask you for a password, and I will give you the password when we're in class. And then after the software is installed and you launch it, then you connect your Logger Pro unit. Make sure this Logger Pro unit is not attached during the installation of the software, so that when you actually attach the Logger Pro unit after the software has been installed and you open it up, it should automatically search for the drivers for that for the data acquisition unit. When you load it up, it should look like this. You have a graph, and in the graph you have a few on the bottom left hand side. You should see the voltage being registered from the DAC system. You should see a little icon that says with a little icon of the actual data acquisition system, and then with the voltage being recorded up there as well. Actually, it's not being recorded, it's just being displayed at this point. So some things you will need to know how to do on this is, first off, how to set sample rate. If you go up to the toolbar here and click on this icon that is titled, as you get close to the icon, you should see that it looks like a little stopwatch, and when you put the cursor on top of it, it'll say data collection. Click on that, and then up comes this window. First off, you'll have right here an ability to select the duration of your data collection, which in this case is set for 15 seconds, the default. So you can set that to however long you want. Here you have actual sample rate, that is the frequency at which you're recording your data. In this case, default is set to 10 samples per second. So, and then over here is the calculated number of samples that you will actually collect. So in this case, you have 10 samples per second for 15 seconds, gives you 150 plus 1. So 151 actual data points will be collected. So if you wanted to change this, say, to 100 hertz collecting sampling frequency, and you set this to 1 second, you should see that the samples to be collected is 101 samples, and so on. So make sure whenever you're about to collect data that you set that according to how you want it to be. And then to actually collect the data, you would go up here and push collect, and then it will collect the data for as long as you've set it for at the sample rate that you set it for. Okay, so that's how you use this, this system in general. I'll go ahead and start collecting some data. I'm going to set my sample rate in this case to I don't know, let's say 500 hertz, and let's say that I'm going to collect for a half a second. In that case, I should have a total of 251 data points. I think that's the case. Let me open this back up and make sure that I'm not saying something that's not true. Yeah, 251 data points, as you can see. Half a second, 500 hertz sampling rate. I go up here, I press collect data. It should collect the data, and then once it's done collecting, display it in the graph, on which the x-axis is time, and the time span should be approximately the total amount of time you collected the data for, and then the y-axis being voltage. So I set the the function generator for its maximum voltage output, which is plus or minus 10 volts. So you can see that that's about true. So in this case, I want to go ahead and export my data, because you're going to need to look at the data in Excel once you collect it. So in this case, you go to File, Export as Text. And then you'll go ahead and title it something. In this case, I'll save it to desktop. You title it as, I'm going to call this test 1. And it should have saved it to my desktop. So I'm going to go ahead and open up Excel. So if you open up Excel and, I don't know, say blank worksheet, just to get to this window, File, you would open, you want to go ahead and open up that one file that we had. So I'm just going to go ahead and try to find my, my desktop here. Let's go over to computer, go to desktop, find my text file here. You might need to go to all files. Instead of it saying all Excel files, go to all files. There is the text file. Go ahead and just press next and finish when a window opens. And here you should see one column with the time and the other column with voltage. And I should have a total of 250 some odd points, 251 points. So down to 258 because there's some space up here. So there you go, and you can use that to analyze your data. Now, you could also, at the same time, if you're just trying to display, if I'll go back to Logger Pro, if you're trying to show something, for example, if you wanted to go ahead and show this plot, or if you wanted to focus in on one cycle, you can go ahead here, and you can actually tell the computer to change the spread of the x-axis. So instead of from 0 to 0.1 seconds or 0.5 seconds, you'll see that my x-axis goes up to 0.1 seconds. And I can see the cycles a little bit better. I can see the digital sampling a little bit more clear here on what points were sampled during the course of the sampling. So if I wanted to go ahead, I can go ahead and screen capture this if you wanted to use that for your experimental memo. Or you can go ahead and plot it in Excel, whichever way you'd rather do it. So the point of this lab is to demonstrate 4 different phenomenon. One is to go ahead and demonstrate saturation. So saturation should be demonstrated by an actual cutoff here above 10 volts. I can actually adjust my output here to be a little bit higher. It wasn't quite set to the maximum. The function generator can go a little bit higher than 10 volts, so I wasn't set to the maximum here, but you should see a clipping up there if the voltage surpasses the Logger Pro's ability to collect voltage. Logger Pro can collect at a maximum of 10 voltage and a minimum of minus 10 volts. So if you surpass that, it just looks like a little cap off the top here. And the only way to do that is to sample the output very fast. So what I mean is if you have 100 hertz output, you would need to actually have a sampling frequency that even surpasses 10 times that amount in order to be able to see the little bit that would clip up here, just due to the fact that you're looking at a very small time window right here, as I displayed by moving the cursor back and forth. According to this, it looks like it's not even 0.01 seconds. Or, yeah, so you're going to need to make sure that you can demonstrate that, which is saturation. Resolution, the minimum step in voltage that the Logger Pro DAC unit can measure is as indicated in your lab handout, is 5 millivolts, 0.005 volts. So in order to demonstrate that, you're going to have to find out a way to actually hone in on a small increase in voltage. I mean, you can probably decrease the max voltage from plus or minus 10 volts to something a lot smaller to show that. And then also, you're going to need to demonstrate aliasing. Aliasing means that the frequency that's displayed on this screen is different than the output frequency that you're actually trying to sample. So let's say this is the 100 hertz sample, right? If you don't, sorry, not 100 hertz sample, it's 100 hertz analog frequency being outputted from this function generator that you're trying to digitally sample and recreate on using Logger Pro. Now, what that basically means is that the frequency that you're going to show here, so if I look at this, this is one cycle, you should be able to demonstrate that the frequency being showed here, the digital recreation of the input signal, is actually going to be less than what the input signal is. So just to clarify what that means is, this is 100 hertz signal that's being sampled by this DAC unit. This DAC unit needs to have a sampling rate fast enough to be able to recreate this 100 hertz signal digitally. This is an analog signal. This samples it and recreates it digitally. So that means that according to the Nyquist theorem, it states that I need to sample at least twice as fast as the input frequency. The input frequency is 100 hertz. If I sample less than 200 hertz, I will have aliasing. Aliasing means that the signal recreated here has a frequency less than 100 hertz, which is the input signal. So that's what you need to demonstrate for graph 3. And then for graph number 4, you need to demonstrate what what the digital signal will look like, or the digital recreation of the input signal would look like if you sampled fast enough. Okay? So those are the 4 things that you need to do for this lab. If things are still unclear, we can clear it up once you get to class. If you have any questions, just come to my office hours or email me prior to coming to class, if you would like.